Okay, let us draw the diagram. This is problem number 1.223. Okay, so let me read the problem. So this says calculate the radius of circular orbit of a stationary Earth satellite. So what we have to calculate is, so this satellite is a stationary. So let us say what I want to say. So I have a satellite here. So this is a satellite. This satellite is moving in a radius of r in a circular orbit. So this is given in the problem. This is a circular orbit. Now this says this satellite looks like a stationary. If an observer is standing on Earth or maybe sitting, observer is standing or sitting on the Earth, so this means a observer from the Earth will look this object or this satellite as stationary. This means if at some point of time this is here, object is here, satellite is here, after some time when this is here, satellite is here, so he will always see something like it is always in one line. This the same angle by which the observer has moved, by the same angle this satellite has moved. So this means this angle in both cases same. So this means this observer will see that satellite is not moving at all. So this kind of satellite is called geostationary satellite, and this orbit is called geostationary orbit. So there are only certain orbit in which the satellite can be look like a stationary. So we have to find what is the radius for this geostationary orbit. So what is the radius? So what is the hint that is given? So this is Earth. So we know in 24-hour Earth rotates one revolution about the axis. So this means time period of Earth I know, that is the 24-hour. So if I know the 24-hour, that is the time period for the Earth, this means the same amount of time this satellite has also to move one revolution. Otherwise both will not look like same. So this theta and this theta is same. This means the angle by which this object has moved is same as the angle by which the satellite has moved. This means both will move by same angle. Are you getting or not? If both are moving by same angle, this means both should have same omega. Both should have same time period, because time period is 2 pi by omega. So you see time period is 2 pi by omega. So if time period is same, omega has to be same. So for both, omega is same. Now let us try how will you find the radius r. I will give you a hint. You find the omega first and then use our equation of motion for circular. So that is force is equals to mass into acceleration. Okay, so I will wait for 2 minutes. So just make a pause on your computer and do some calculation. And if you are not doing calculation, just listening, that this does not have any meaning. So you will have only the active reading only if you do some calculation on your copy. Otherwise just say like a movie, you are listening something that has no meaning at all. It has no meaning at all, very frankly speaking. It might be look like interesting, but it will not help you. You have to do your own calculation. So let me wait for 4 minutes. Make a pause. Okay, so some of you have done correctly. So let me go. So this is Earth for E. So time period for Earth is, I can know T is equals to 2 pi omega. Time period for Earth is, everybody know this, 24 hour. So now I know omega. Omega is 2 pi by TE. Now this is the same angular velocity for satellite also, because satellite and because basically both have same angular velocity, we have already explained. So now if we apply total force toward the center, so total force is gmm by r square. This is equals to m omega square r. Total force is equals to mv square by r, and v can be also written as r omega. So this becomes m omega square r. And omega is nothing but 2 pi by t, because for omega for satellite and omega for Earth will be same. So if you put this value, you can find this r. And getting our next part is just calculation. So you see, you will find r. Now you see, m is fixed, g is fixed, t is fixed. So I will find what is the radius for geostationary orbit. Now this is a fixed radius. I will have only one radius at which I will find the satellite will look like a stationary. This means there are many countries in the world. If all wants to place their satellite as a geostationary satellite, they have to put in the same radius. So this means now there will be a fight. Some countries throwing, some other countries throwing. So maybe these two satellite can basically you can see very near to each other. I'm not saying they can collide. Basically, it's a so big circle, it is impossible to collide. So basically what the countries have done, they have divided this part to this part of the space is in my region. So I will place in this region my own satellite. Some other country has said, this part is in my region. I will place up to this part my satellite. So this means now there is a division of a space. So let us say some will say, I will place my satellite in this region. Some other country will say, okay, I will place my satellite in this region. Some other will say, I will place my satellite in this region. So there is a division of a space. So this is all about this problem. So this is something related to geostationary orbit. If you have not written, just let us copy it down and we will discuss the next problem. Make a pause and copy it down.